Hello everybody. Hello, hola, willkommen, namaste, as I am in Indian. My name is Akshay Vagasya, and today I am going to show you how exactly we can install Xenomai 4, a real-time system which is capable enough for hard real-time softwares. So how to install Xenomai 4 on Raspberry Pi 4? So which Raspberry Pi I am going to use, which SD card I am going to use, and what are the things we are going to do. So we will see you in the videos. So let's go. So I'm going to use first, this is a Raspberry Pi 4B model, and yeah, with 4 GB RAM. So yeah, we are going to use that one. Yeah, behind you can see my friend. But yeah, so Raspberry Pi 4B, yeah, and this is the model with 4 GB RAM, and I am going to use 64 GB SD card for the better purpose. Maybe you could use the 16 GB also and 32 GB also. So yeah, let's see. With my Raspberry Pi, this has a Raspberry. This is Raspberry Pi 4B with the two HDMIs. Right now we don't need it. We just need a one HDMI, and yeah, it is updated version of 3, and the Raspberry Pi 5 is available, so also you can order it. So yeah, let's start it. So let's first of all install our Raspberry Pi OS on a SD card. So first we have to select our device. So yeah, I'm using Raspberry Pi 4, so this one would be the for device 4, and I prefer 4 GB, yeah, 64-bit, because I'm going to use 64-bit for my Xenomai 2. So yeah, you can use this one, 64 GB latest version, and this one is device 64 GB with that one. So let's do next. And would you like to apply customized OS settings? So yeah, first of all I have when I yeah, so we are going to, because we are going to prepare this one, so this is going to be rpx, and this is my password. Yeah, so this is going to be my password. Then this is my Wi-Fi, and yeah, it has already the password. So yeah, everything is fine, and yeah, it's done. So just to save it, yeah, and yes, yeah, we are going to lose every data of your hours, so let's do it. So now let's install our data, and let's see that install our OS, and let's see that it is completed fine or not. So yeah, now is very fine, and yeah, finalizing now, it's done. Let's see, and just plug it in our Raspberry Pi, and let's move forward to our Raspberry Pi screen, and next further process. So yeah, this is my Raspberry Pi, and now you can see this is my rpx Raspberry Pi. This one is uname minus r. This one is OS, and this one is Debian 6.6.5 Linux Raspberry Pi OS 6.6.51. This is RPI version 8 kernel. So first of all, we have to download our Linux system, also our Linux EVL means Xenomai 4. So first we are going to get our Linux system. So yeah, let's clone first. Let's go and clone it first, then we can clone it another one. So yeah, let's go. So it will take around 2 or 3 minutes. So let's see. Yes. So now it is successfully downloaded, and we will see that it is downloaded successfully. So yeah, just City Linux, and we also can see in the folder of City Linux. So yeah, let's see it. Yeah, little Raspberry Pi is taking little bit time, maybe because of our ah, I have opened so many folders. So this one is our Linux file, and in our Linux file there is a kconfig file, but we can see our show hidden files, and you guys can see or not that .config file. So it should be in a kind of a boot file. Yeah. So let's see first of all IPC Linux kernel, and no tools, sound, script, Rust, iOS, include crypto. Yeah. So first of all, let's put another thing in the download, and then we can find our .config file, because it is necessary, and yeah, it's really important file for us. Some yeah. First of all, let's put Xenomai 4 in the download, then we can find that file. Yeah. So now it is downloading our Xenomai 4, and we should first of all we should find our the file of yeah, that .config file. So in Linux there is no config file. Why? Kconfig, maintain, makefile, readfile, creates, clang, main. Yeah. So I don't think so. We don't have a, I think we don't have a this file which is called C file. So we need to generate it. So let's generate it first. .config file, not a C file. So yeah, let me generate it. Yeah, but first of all, after, otherwise we can open the new tab, and yeah, we can go to the Linux folder, and now we can generate our .config file for the Linux. So yeah, there will be our config file for the Linux. And yeah, let's see that download is where. Yeah, so now there is a download. So maybe in our Xenomai folder we can see that our .config file is available or not. So yeah, let's see. No, it is not available here also. So okay, let's go. So now we can copy our Linux eval file into our next files. So let's copy and paste it. Oh, there are two errors. What is it? That maybe we have to do make menu deconfig. So we are getting these errors because of missing packages. So let's first of all just install it, then we can decode the file. So first of all install these packages. These are the packages that yeah, git bash and flags, then yeah, libssl and all these packages. So first of all we have to install it. After that we can do deconfig and generate our .config file. So let's wait. Okay, now we can go in cd linux and we can see our file that yeah. So now we can generate our file, which is yeah. So now our .config file is ready, and we can copy and paste it into our linux eval file, so we can have the same drivers. So let's go to the linux eval. Yeah, so now it is copy pasted, and we can go for further process. So yes, now we can see that our config file is there or not. So once config file is generated, so now yeah, we have config file. Then now we can do make menu config for our build. So let's do make menu config. Yeah, so in this one we have to select some options. So first, in a general setup we can select local version. So maybe let's go in a general setup, and in a general setup we have the local version is v8. So maybe we can name it whatever we want or whatever we like. So yeah, as it is, or you can keep it as it is also. So but let me give the local name that Xeno version 8. Okay, so now we have set up our local version. Then kernel.config support. So another thing is kernel.config support, we have to enable it. So there is option of kernel.config support. Yeah, so it is already on, and this one is already also on, so we don't need to change anything. Then we can go back in the exit. Then we can go in another part, which is kernel features. So where is kernel features? It is here. Kernel features. Yeah, no, this one is kernel hacking. Kernel features for EVL. Where is our kernel features? Yeah, this one is kernel features. Now in a kernel features we can go in EVL real-time core. So let's go in that one, EVL real-time core. Yeah, in this file we can enable our debug support, EVL real-time core and debug support, but there is no debug support. So let's exit EVL real-time core. So first of all, in this one, yeah, just select this one, then we can add the debug support, then just save it. Okay, and exit. Yeah, so now also we can add a timer frequency. We can do timer frequency to 100. So just we need to go back once, then we can do it. So yeah, this one is a timer frequency with 1000 megahertz, 1000 hertz. So let's see the timer frequency first. So timer frequency is in kernel features. In the kernel features there is a timer frequency. Where is the timer frequency? Yeah, there is a timer frequency 215, and now we can do it 100. Okay, so now we can exit this one, and last is the CPU power management. In the CPU power management we have to go in a CPU frequency scaling, and in a CPU frequency scaling we have CPU free governor. So yeah, this is a CPU free governor. It is in on dimmed. We have to make it as a performance. So yeah, now you can save it. Okay, okay, and now you can exit from the whole menu part. So now our menu is done. Okay, now let's move further to another part. Make menu config is done. Kernel configuration options. So yeah, make sure that you enable specify kernel configurations, such as config Xenomai to enable Xenomai support, then config core to Xenomai functionalities, then Xenomai config Xenomai kernel if you are integrating Xenomai into kernel directory, or other Xenomai specific based option, whichever you like. So first of all, maybe let's see in our config file. Yeah, let's see in our config file, and yeah, in this file and in our config file we can see that do we have that config Xenomai enabled yes, or Xenomai core enabled yes or not. So first of all, let's go to the Xenomai EVL, then we can go in the .config file. Yeah, in this config file let's find our config. Config Xenomai. Yeah, so it is not available, so we have to add these lines in our file. So first of all, let's add these lines in the config file. Yeah, Xenomai is not available in the total folder, so let's see. So we can add these two lines in our file. This one is here. Yeah, now you can close this one. Yeah, so it is added. Now you can check it that Xenomai is available or not. Yeah, config Xenomai is available in the board part. So yeah, now we have to make the build. So yeah, we have done the setup everything. Then now we can put our images and everything in the Mac folder. So let's install this Mac. We are using 4 codes, so we will use Mac 4 command. Okay, so yeah, let's see. You can see this command. It will take around 2 or 3 hours. So yeah, see you later after 2 or 3 hours. If there is an error, then please check it, and maybe there is no error for that one, but yeah, if you got any, please check it. See you in 2 or 3 hours. So as you can see guys, right now we have successfully built the our Xenomai 4 libwell, and now we can install some modules. So let's go with first of all let's make the modules, then we can install it. So yeah, now we can make the modules and install it. Yeah, yeah, as you can see, is our 6.12.8 Xeno minus V8 plus. This was our system. So, yeah, it is successfully done. Now we can okay. Yes. Now we can copy our all the database to our main file, which is our main line kernel. So yeah, our all the developed built database in arc arm64 boot dts, and we are going to put this in our boot file in all the database. So yeah, Broadcom, and it's database of Broadcom. We have to put here boot also. Okay, it's saying that minus r is not specified directory. What is it exactly? I have to check it. Let's see. In this format, but we have to check the Linux CVL. There is error something. Let's see what it is. In our arc, in our arm64, in our boot file. Yeah, these all are the DTS. welcome boot dts. Yeah, our error was the path. We have all this database in this one, in this file. So yeah, let's do it again. It's we have every database in a Broadcom and it is in a DTB. So yeah, here we have every database and there is a file called a Broadcom, and yeah, we have all this database in a Broadcom file in a Linux UL. So be sure that you have perfectly built Linux UL file. Yeah, now I have my system database in my firmware and boot. So yeah, I will put this path in our way. So now everything is fine. So okay, let's go. Now we have all the copied database. Also we will need our kernel image, which is main kernel image. So let's copy it first. What is the name of our kernel image? As we can see here in our boot firmware, and our kernel image name is there should be .img file. So let's find out .img. Control F. Okay, there is, yeah, this one is kernel 8.img. So we have to make that path. So we are giving this one to our main kernel line, kernel 8.img, and yeah, now it is copied successfully. So now we have to add our name, which is not necessary. Sometime you can edit, sometime you don't need to edit. So yeah, in our config file, so just go to your bootloader where you have a main kernel and just go to your config file. So first of all we have to find out where is our config.txt file. In this one, so yeah, it should be in a boot. So yeah, we have this our config file. In this config file, do we have, oh yeah, we have overlays, this make frame dt overlay. Okay, 4 5 6. Okay, yeah, everything is fine here. dt overlay mode all. In this config file we have to add this one. So it should be, just add these lines. Yeah, kernel is equal to kernel 8.img and dt overlay is our evl. Okay, now just save it and close it. Okay, this one is right now read only file. So what we are going to do, we will just open it as here terminal. So first open current folder in a terminal, then we can copy this file name and we can do sudo nano, and now you can edit this file. Okay, and now you can paste those things here. Sometime you have to do some things via terminal, not a terminal, but yeah, look at this, and yeah, everything is now just to save it. Now it's done. So yeah, 90% work off is done right now. Now we can see everything is fine. Now we have to reboot the system, and then we can uh, see our main kernel. So let's reboot the system. As we have rebooted our system, reboot is done. Now let's see our name of the kernel and name of the system. Uname minus r, and yeah, so you can see the customized kernel 6.12.8 and Xenomai minus version 0.8 that we have changed in make menu config, if you remember it. Yeah, sure, you are a clear developer. So okay, then yeah, this one is yeah, primed evl. If you are using a primed rt, then there is another way which I am going to upload the video, so you guys can check it also for primed rt too. But now let's focus. Now we can see, or we can check, or we can test or benchmarking that every function of libevl, which is Xenomai 4's all the parts or libraries, is functioning or not. So how we can see it, or how we can run every libraries or evl tests. So let's see it. It will not take more than 5 minutes. Yeah, so first of all we have to clone the git, which is here. I have all these links prepared already, so video will not take that much long, that's why. Yeah, now we have successfully tweeted. Now we can go into that folder, or maybe we can make another library. That is not an issue at all. So yeah, let's make another library. It's for build. Yeah, now it is made. Now just we need to go it in. Yeah, and we have to compile our mason. This is also why I am compiling this, because it is shown also on the website of Xenomai 4 on a benchmarking page. We have to set up all these headers and everything. So this is the common part for everybody if you are using Ubuntu or any Linux or something like that. So yeah, we have to change our name Apex, and yeah, this one would be the Apex 2. Yeah, and now our mason setup is going on. Yeah, it's a successfully setup. If you sometime you could get errors too, like cmake file is missing or there is library missing, so you need to install it via on your own, or maybe you can take guidance from Stack Overflow or from the internet or something like that. That's not issue at all. Small issues happening when you compile the mason. So yeah, now we can compile the mason. Yeah, let's see our Mason is going on. So what will be the result? It will be the good. So let's see. And by the way, I would like to inform you that I have uploaded a primed RT, yeah, Primtion real-time systems, how to attach the patches. So where in Raspberry Pi in a latest version. So I hope you guys will love it, and you guys can take suggestions from them. If I'm wrong anywhere, then I would like to also improvise everything. So please, yeah, suggestions are always welcome. So yeah, now we can install our Ninja. Ah, yeah, now everything is fine, and I think we are good to go. So first of all, let's verify the installation. We should see lib evl.so4.so, not a 4 .so file, or maybe local bin or evl. So let's see first it is successfully installed or not. Ah, there is no evl group or something like that. And if in local library or in a local bin, wow, it's not there, that means we have kind of issue or something like that. So we have to check it. Yeah, evl is there, but libevl is not there. So we have to generate that so file. So how we are going to do it? But first of all, we have to run it, the test. If it is not running, then we can do it via solution. So first of all, let's go there here. Yeah, and let's run .evl file. Oh, while loading shared library less work. Okay, cannot open. So yeah, it is not going to work. So first of all, what you should do, you should give the right path to the right array. So just you can do it, give it via this command. We are making the path universal. So yeah, this one will be the user local lib. Okay, yeah, then we can do sudo ld config. Why sudo ld config is not? Let's check. Do we get SO file or not? So maybe no, SO file is missing. Okay, so the problem is, so this is the error of libso4. So we have to check that where is this file, because this couldn't get the libso4 file. So you can check it in logs also, that where is the exactly the libso4 file is. So yeah, this file is installed in a user local library. Okay, yeah, arc64 linux xenu. Okay, then you need to just open that thing. Yeah, and now you need to see it is confirm that that yeah, the libso4 file, yeah, evl.air is available. So now you need to give that path to the everywhere. So yeah, just via this command you can give it to everywhere. Yeah, so now it is in user linux everywhere. So yeah, I mean, you can exit it. Then now you have to do sudo config. Now it's fine. Now we can see, yeah, now the libsl file is available. So now we can proceed for a further step. Yeah, so our sl file is available. Now let's see that our file is available or not. So let's go. Now it is export. Now we can set this path for the library or user local. So yeah, let's set this path for the library and user local. So now we can do this bash file to make persistence across the session. So let's do it again. It's echo. Yeah, so now you can see it. Let's check the source. Okay, now let's run the test. Okay, .evsl file is not found. Then we have to find the location. So where is the location? Location is here. Just we can open this file. Or maybe direct we can do sudo evltest. Yeah, so now you can check it that every fault, every basic xfu and everything fault maybe preload everything of Xenomai 4. All the libraries are working perfectly fine. For the last latency and everything, you can see this step, like just go to this path where our EVL file is located. Now you can see the EVL path or that Latmus test. Okay, that file I think is not available. Yeah, we have to find a sudo, and this one is a Latmus latency. So yeah, finish for the blog. And yeah, there are some errors, but also I have given the solution how you can solve it, so that's not a problem. So yeah, just watch this video and do your development in real time systems, because everything is real time.